Real-time systems are about connection management, ordering, delivery guarantees, and presence. When I think about real-time chat, I start with the real job. One-to-one and group chat, where messages must feel immediate while still surviving reconnects and offline states. Before we pick components, be clear about the workload. This design has to handle WebSockets, message storage, delivery receipts, online users, ordering, fanout, push notifications, presence, typing indicators, and scaling connection gateways, not just a clean demo request. The first diagram usually looks fine because it only tells the happy path story. For this topic, that naive version is usually the web app writes messages straight to the database and clients poll for new rows. I still start simple on purpose. The smallest version that can work here is the web app writes messages straight to the database and clients poll for new rows. That gives the team a baseline before complexity earns its place. Next, I walk one normal request or event through the simple design. That is where the useful questions start, because the path reveals what each component actually owns. The problem is not that the simple version is wrong. The problem is that it ignores what production will demand next. Message ordering and duplication become hard once users reconnect across devices and regions. The first production pressure usually shows up here. Message ordering and duplication become hard once users reconnect across devices and regions. That is the moment when a pleasant diagram turns into an engineering decision. Then operations gets involved. If the design cannot be observed, rolled out, and recovered safely, the system is already too expensive to own. In this topic, that pain looks like presence, typing, and unread counts are cheap in demos, but expensive when connection volume rises. And then comes the part junior diagrams almost always skip. Without durable storage and delivery semantics, a real-time UI can feel fast while still losing trust. That is where production-grade thinking separates itself from feature demo thinking. So the better design adds only what solves a real problem. For this topic, that better shape is WebSocket gateways, message persistence, pub-sub fanout, ordering keys, delivery status tracking, present state, and push notifications for offline users. This is what you gain from the stronger design. You get low latency interaction with clear delivery and reconnect behavior instead of unreliable polling hacks. Those gains are why the extra complexity is sometimes worth it. But there is always a bill to pay. The cost of the stronger design is you now own connection scaling, fan-out strategy, ordering guarantees, and more operational state. That trade-off is the real system design conversation. Now I challenge the design with a failure question. Ask what happens when a user goes offline mid-send. The WebSocket tier is overloaded, or the same message fan-out reaches several devices out of order. If the diagram cannot answer that honestly, it is not ready. So the final architecture story is simple. Trace one chat message from client send to gateway, persistence, fan-out, receipt handling, presence update, and offline notification fallback. That is the version I would be comfortable defending in a serious review. If you remember one thing, make it this. Viewers learn the core architecture behind chat apps like Slack, WhatsApp, or Teams. Good system design is a judgment loop, not a memorized answer key.